Hello, my fellow Americans. Welcome to this week's edition of The O'Reilly Factor. I'm your host, Bob O'Reilly, and as a part of this week's educational special, we'll be continuing our study of organic chemistry, moving on to the hydration of alkene reactions. And ladies and gentlemen, this week we have a very special guest with us, President Barack Obama. I think the audience would like to hear their president define what hydration of an alkene means.
Well, what Michelle always told me was that hydration of an alkene involves the addition of a hydrogen and a hydroxyl group across what used to be a double bond in an alkene.
Little fumble, no big deal. So, Mr. President, how about you start off by showing us an example mechanism of hydration of an alkene, and then maybe walk us through your mechanism to explain it to the audience.
I think I can do that.
All right, well, let's see what the President will have for us. We're going to go to a quick commercial break, and we'll be back in a minute. I wonder what the President is up to out there. Welcome back, America. President Obama here has been kind enough to prepare a demonstration of acid-catalyzed hydration. He has drawn the mechanism for you, and he is going to walk you through it step by step, explaining how it works. And let's hope he's a little better at this than he is at playing basketball.
I'll give it my best shot, America. So what we see here is we start with a terminal alkene, and then we react it with sulfuric acid and water to get an alcohol, a tertiary alcohol. So we start this by reacting this alkene with hydronium. So this pi bond acts like a nucleophile and strips the hydrogen off of the hydronium, and the electrons go back over to the oxygen to make this structure more stable. And then from this process, we get a secondary alkane product, which is also a secondary carbocation. Now, change has to happen in America for this to be stabilized.
Oh, here he goes again.
So, a hydride shift occurs, and we get a tertiary carbocation product right here. Now, water acts like a nucleophile and attacks this positive charge, and we get an alcohol with a hydronium attached to it, actually. So there's an extra hydrogen right here. Now, water comes in, acts like a nucleophile once again, and strips this hydrogen off, thus creating our tertiary alcohol product. And because
Secondary carbocation is not as stable as the tertiary carbocation?
it is not.
So the change is necessary.
The change is necessary. Change is real, and I will bring change.
That's interesting. Don't get too overzealous. Thank you, Mr. President. Now, there's actually another alternative that me and my team of underlings have kind of dug up, and I'll prepare that mechanism for you, and then after this commercial break, we'll share it with the audience. The method I chose to use is oxymercuration followed by demercuration. So what we have here are alkene acting as a nucleophile, attacking mercuric acetate, attacking here at the positively charged mercury and shifting the electrons over to the more stable oxygen. The result of this is the mercurinium ion will form. And this bridged ion is not as stable as it could be, which is why our water molecule will attack the more substituted electrophilic carbon. When the water molecule attacks, the acetoxy mercury group will pull away from the attack site and form over here. At the attack site, what will happen is the hydronium ion will form here, and water will again deprotonate, yielding our alcohol. But we're not done yet, because the acetoxy mercury group is still here, and we don't want that. So what we're going to do is bring in sodium borohydride to remove it. The negatively charged hydride will attack the acetoxymercury group with the remaining electrons moving back onto this carbon, yielding our alcohol, the most substituted Markovnikov formed alcohol, otherwise known as, you might like this, President Obama, menthol. So, of course, excluding stereochemistry, this would be your product.
Well, Mr. Arila, can we at least agree on this? We can make the least substituted alcohol product by using hydroboration?
Yes, I suppose, actually, I think we can agree. That's interesting. But, unfortunately, we don't have time to discuss the mechanism for that today. Thank you for your time, President Obama. Hopefully, next week, we will have time to discuss the mechanism for hydroboration with our special guest, Ron Jeremy. That is, of course, after we discuss the synthesis of sildenafil citrate. I'll see you next week, America. And once again, God bless America and no place else.